Energy Flow in Ecosystems, Chapter 2, Lesson 1. What are the energy roles in an ecosystem? Do you play an instrument in your school band? If so, you know that each instrument has a role in a piece of music. Similar to instruments in a band, each organism has a role in the movement of energy through its ecosystem. An organism's energy role is determined by how it obtains food and how it interacts with other organisms. Each of the organisms in an ecosystem fills the energy role of a producer, consumer, or decomposer. Producers. Energy enters most ecosystems as sunlight. Some organisms, like plants and algae, and some types of bacteria, capture the energy of sunlight and store it as food energy. These organisms use the sun's energy to turn water and carbon dioxide into food molecules in a process called photosynthesis. An organism that can make its own food is a producer. Producers are the source of all food in an ecosystem. In a few ecosystems, producers obtain energy from a source other than sunlight. One such ecosystem is found in rocks deep beneath the ground. Certain bacteria in this ecosystem produce their own food using the energy in hydrogen sulfide, a gas that is present in their environment. Consumers. Some members of an ecosystem cannot make their own food. An organism that obtains energy by feeding on another organism is a consumer. Consumers are classified by what they eat. Consumers that eat only plants are herbivores. Some familiar herbivores are caterpillars, rabbits, and deer. Consumers that eat only animals are carnivores. Wolves, walruses, and snakes are some examples of carnivores. Consumers that eat both plants and animals are omnivores. Crows, bears, and humans are omnivores. Some carnivores are scavengers. A scavenger is a carnivore that feeds on the bodies of dead organisms. Scavengers include catfish and vultures. Decomposers. If an ecosystem had only producers and consumers, the raw materials of life, such as carbon and nitrogen, would stay locked up in wastes in the bodies of dead organisms. However, there are organisms in ecosystems that prevent this from happening. Decomposers break down biotic wastes in dead organisms and return the raw materials to the ecosystem. You can think of decomposers as nature's recyclers. While obtaining energy for their own needs, decomposers return simple molecules to the environment. These molecules can be used again by other organisms. Mushrooms, bacteria, and mold are common decomposers. How does energy move through an ecosystem? As you have read, energy enters most ecosystems as sunlight and is converted into food by producers. This energy is transferred to the organisms that eat the producers, and then to other organisms that feed on the consumers. Energy moves through an ecosystem when one organism eats another. This movement of energy can be shown as food chains, food webs, and energy pyramids. Food chains. One way to show how energy moves in an ecosystem is with a food chain. A food chain is a series of events in which one organism eats another and obtains energy. Food webs. A food chain shows only one possible path along which energy can move through an ecosystem. Most producers and consumers are part of many food chains. A more realistic way to show the flow of energy through an ecosystem is with a food web. A food web consists of many overlapping food chains in an ecosystem. Organisms may play more than one role in an ecosystem. A crayfish is an omnivore that is a first-level consumer when it eats plants, but when a crayfish eats a snail, it is a second-level consumer. Just as food chains overlap and connect, food webs interconnect as well. A gull might eat a fish at the ocean, but it might also eat a mouse at a landfill. The gull, then, is part of two food webs, an ocean food web and a land food web. All the world's food webs interconnect in what can be thought of as a global food web. Energy pyramids. When an organism in an ecosystem eats, it obtains energy. The organism uses some of this energy to move, grow, reproduce, and carry out other life activities. These activities produce heat, a form of energy which is then released into the environment. When heat is released, the amount of energy that is available to the next consumer is reduced. A diagram called an energy pyramid shows the amount of energy that moves from one feeding level to another in a food web. The most energy is available at the producer level of the pyramid. As energy moves up the pyramid, each level has less energy available than the level below. An energy pyramid gets its name from the shape of the diagram, wider at the base and narrower at the top. In general, only about 10% of the energy at one level of a food web is transferred to the next higher level. Most of the energy at each level is converted to heat. Since about 90% of the food energy is converted to heat at each step, there is not enough energy to support many feeding levels in an ecosystem. The organisms at higher feeding levels of an energy pyramid do not necessarily require less energy to live than the organisms at lower levels. Because so much energy is converted to heat at each level, the amount of energy available at the producer level limits the number of consumers that the ecosystem is able to support. As a result, there are usually fewer organisms at the highest level in a food web.